Hello everyone, welcome back to the channel. In today's lecture, we are going to understand one of the most important concepts in electrical engineering, RMS voltage. RMS voltage. So this topic is very important for exam, interviews and the practical electrical system. So let's watch till the end. What is RMS voltage? So first, what is RMS voltage? So RMS means root mean square. So this is root mean square. Root mean square. RMS means roots mean square. So it is the method of expressing the effective voltage of an AC signal. So we can say that effective voltage of an AC signal In simple language, RMS voltage is the AC voltage. So this is a AC voltage that produce the same heating effect that produce the same heating effect or power in register in register as a DC voltage. So this is the simple definition of RMS voltage. So we can say if AC voltage is 230 volt that actually means 230 volt RMS, 230 volt RMS, not peak voltage. So this is a simple definition and explanation of RMS voltage. Now we'll see why RMS is needed. Now we'll see why. First, this is what. After this is what is RMS voltage. Now why we need this RMS voltage. As AC keeps changing, positive and negative. So if we draw the waveform, so from the waveform what we can say, so this is the initial point, this is the zero. So what we can say, so it's continuously increasing. So this is the maximum value, again it is decreasing to 0. So in the negative way it is increasing, again it is go back to 0. So that AC continuously changing from positive to negative. If we simply take the average of this waveform, then this positive and negative will be cancelled out. So in that case, average voltage will be 0. Average value will be 0, which is useless. So what we can do, we square the wave. Square the wave makes all values positive. Makes all values positive. So makes all values positive. So take mean, then take mean and then square root. So that's why the name is root mean square. So that's why the name is root mean square. So this is the RMS. So this is the RMS value, that is root mean square. Now if we consider a waveform, so first we'll draw the waveform. So if this is the waveform, and this is VT, and this is VM, that is the maximum value, that plus VM, and this is the minus VM, means for the positive waveform this is the maximum value, and for the negative waveform, negative half, this is the maximum value, and this is 0, and this is the total time period. So from this waveform, what we can write, VT is equal to VM sin omega t. We can write VT is equal to VM sin omega t, where VM is the peak value. So this VM is the peak value. And the waveform goes positive VM. So this, if positive waveform will start from here, then it will go to the positive. So this is the plus VM, plus VM. Again it comes to 0. This is 0, and again goes to minus VM. This is minus VM. Again go back to 0. So this is the repeat this cycle. So now we'll see the mathematical definition. mathematical definition. Mathematical definition. Mathematical definition. So as a mathematical definition, what we can write, VRMS is equal to root 1 by t integration 0 to t v square t dt. So this is the mathematical definition of RMS value. This means square the voltage. So that square the voltage. So this is, can it square the voltage, take the average. Then take the average, take the average, take the average over time, one time period, over one time period. Take the average one time period and take square root. Then take square root. Now, according to the waveform, so for sine wave, for sine wave, uh, for pure sine wave, the formula becomes VRMS is equal to Vm by root 2. So that is 0.707 Vm. So this is for the sine wave. So that means RMS value is 70.7% of peak value. So RMS value is 70.7% of peak value. Okay, now we'll see some important relations like Vm is equal to, we can write root 2 V RMS, then V PP means peak to peak, peak to peak voltage. Peak to peak voltage is equal to 2 Vm. 2 Vm means, so this is the one peak and this is the another peak. So that is V peak to peak is equal to 2 Vm. Now we'll see the from the circuit diagram. If we draw a circuit diagram with one voltage source and one resistor, simple. If we consider this is the AC source connected to a resistor. So this is 230 volt RMS. 230 volt RMS. The power consumption is exactly same as 230 volt DC. So here, what we can write, power consumption power consumption power consumed is exactly same as 230 volt DC. 230 volt DC connected to same resistor. Now we'll see the power relation. So in power relation, and in case of that power relation, what you can write, P average is equal to V RMS square by R. So exactly same as DC formula. So this is same as DC formula. Same as DC formula. So that's why RMS voltage is called effective voltage. RMS voltage is called effective voltage. So now we'll see a simple example where RMS value, suppose V RMS is equal to 230 volt. R is equal to 100 ohm. So IRMS is equal to 230 by 100. So that is 2.3 ampere. And P is equal to, that is 230 square by 100. So that is 5 to 9 watt. So this power would be same if a 230 volt DC was applied. This power would be would be same even if a 230 volt DC was applied. So that's the importance of RMS. So that's the importance of RMS. This is all about RMS. This is all about RMS voltage. So simply that RMS means root mean square, and we can say this is the effective voltage. That's all. So if you like the explanation, don't forget to like this video, share with your friends. Thank you.